Welcome to the Chapter 4 review. This is for pre-algebra. It can be found on page 210 of your textbook. And we're going to start with number 6. The directions for number 6 is write the prime factorization of the number. And whenever you see prime factorization, we're talking about the trees. So we're going to start with 104, and you want to think to yourself, what times what goes into 104? And two products that can be multiplied to get 104 are 2 and 52. 2 is a prime number, so I'll circle it. And then 52 would be 2 times 26. And 26 would be 2 times 13. And 13 is a prime number. And so the prime factorization is going to be 2 to the 1, 2, third power times 13. All right, so we're going to do the same thing with number 8, which is 138. We're going to do the tree, and 138 is even, so I will say 2 times 69. And then what two factors give us a product of 69? Well, I can see that 3 will go into 69 23 times. And so 3 is a prime number, and 23 is a prime number. So the prime factorization of 138 is 2 times 3 times 23. All right, we have, for number 10, we're going to factor the monomial, and we have 98x to the third y squared. And the way we do this is we use prime factorization with the 98. So I'm going to do that over here. 98, 2 times 49. 2 is a prime number. And 49 we can create by 7 times 7. And 7 is a prime number. And so what we have is 2 times 7 times 7. Then we have to deal with these three x's, x times x times x, and 2 y's. And now we have factored the monomial. All right, number 12, we're going to do the exact same thing. We're going to take 15, use prime factorization. Well, that's 3 times 5. Those are both prime numbers. So 15 will be 3 times 5. And then we have times r times s times s. So the monomial factored is 3 times 5 times r times s times s. All right, we've got to find the greatest common factor, and we're going to use method 2 for this. And method 2 is where we use prime factorization to find it. So we're going to do 32, and we're going to do the prime factorization. So that would be 16 and 2. And 2 is a prime number. 16 we can create by 8 times 2. 8 we can create by 2 times 4. And 4 is 2 times 2. So we've got those two are prime, and that is prime. So for 32, we would have 2 times 2. So there's 1, 2, times 2, times 2, times 2. And now we just have to do 64. 64 we could do 2 times 32. 32 we did already, which was 16 and 2. Circle my prime numbers. 16 would be 2 and 8. 8 would be 2 times 4. And 4 would be 2 times 2. So we've got 1, 2, 3, 4, 5, 6 2's. 1, 2, 3, 4, 5, and 6. And now, to find the greatest common factor, we look at the number of sets that are shared. So we have 1, 2, 3, 4, 5 sets that are shared. And if we do 2 times 2 times 2 times 2 times 2, it equals 32. And so the greatest common factor is 32. All right, for 16, we are going to find the greatest common factor of three numbers, 15, 42, and 63. And we're going to do it the exact same way. We're going to have to use the prime factorization. So we'll start out by doing that for 15. And 15 would be 3 times 5. Okay, then we will do 42. And 42 we could do 2 times 21. 21 is 3 times 7. And so what we have here is 42, 2 times 3 times 7. And then we have to do 63. And 63 would be 3 times 21, 3 times 7. And so 63 is 3 times 3 times 7. Now we look to see what's shared between all three of them. And the only thing that's shared is one set of 3's. And so the greatest common factor for these three numbers is 3. All right, for number 18, they're asking us to simplify, and we're going to use the method that uses prime factorization. So 12, we would use prime factorization, would give us 2 and 6, and 2 and 3. And so 12 would be 2 times 2 times 3 over 21, and prime factorization would be 3 times 7. And so what you do is you cross out what's shared, and then you multiply what's left. So 2 times 2 would be 4, and then the denominator would be 7. And so simplified, 12 21st is simplified to 4 sevenths. Number 20, 30 over 72. We're going to do the exact same thing. Prime factorization, 3, 10, 2, 5. So 30 would be 2 times 3 times 5 over 72, which is, 72, which would be 36 times 2. And 36 can be 3 times 12, and 12 can be 3 times 4, and then 4 would be 2 and 2. So we've got 2, 3, 3, and 2 2's. 2 times 2 times 2 times 3 times 3. Now we look at what we can cancel. We can cancel one set of 2's, one set of 3's. So our numerator is going to be 5, and our denominator is going to be 2 times 2, which is 4, times 3, which is 12. Now number 22, in a normal situation, we would use prime factorization for the number, but in this case, both numbers are prime. So what we have here is 5 times c times d, and on our denominator, we've got 2 times d. So we can't cancel anything with the numbers, but we can take a d off at the top and the bottom. And so this simplified is 5c over 2. You could also write this answer as 2.5 c. 24, we're going to use prime factorization, and 22 is 2 times 11, and 11 is prime. So up here in our numerator, we're going to have 2 times 11 times m times m times n. And our denominator